Hello and welcome everyone to IXIA and You Nuggets. For those who don't know me, my name is Chris Gabrielson. I'm a technical leader in our enterprise switching space within Cisco TAC. And these videos are designed to be relatively shorter videos that are no frills, straight to the point for an engineer who's maybe in a hurry. You've taken a case, it requires traffic generation, and you don't even know where to start. So for this particular video, we're going to be focusing on an introduction to what's going on. And this is also going to be very beneficial if you're maybe a new hire who's joined Cisco and we're introducing you to the concept of traffic generators. So when we look at our agenda, we're going to start off by talking about what's an IXIA and why do we use them? What benefits does it provide us to use a traffic generator? Once we understand the use case, we'll go into connecting to one from our Kalo case details. How do we translate what's in a Kalo case to action items for us? Then, once we're connected, we'll go over some basic navigation of the IX Explorer application. And this is going to include things like L1 port negotiation, essentially making sure your physical interfaces are up and ready to pass traffic, as well as going over things like port ownership and some view controls. What buttons do you click? Which ones do we not care about? How do you basically get to a point where you could start sending traffic? And the use cases for this is that all my subsequent videos, they're going to go into more detail in terms of how to generate very specific flows depending on what your use case is. And they're going to assume you've gone through this video and understand all these basics. How to get connected, how to get port ownership, and how do you get to a point where we could dive right into traffic generation. All right, so with that being said, let's go ahead and dive into some of our content. And one thing I want to say as well before we start talking about the IXIAs, this video is being recorded in 1080p, which means a little bit later on when I share my screen, we will see potentially some of the words will be very tiny and I really can't increase them a whole lot. So if you're viewing and something is a little hard to read or it seems a little pixelated, be aware you might need to change your video playback settings. Or if you're watching this video within the Box web folder application, you may need to download the video as a whole and just watch it offline in something like VLC. That should preserve the full 1080p quality. All right, so with that being said, let's talk. What is an IXIA? An IXIA is going to refer to a modular chassis that contains a very powerful set of line cards which have the ability to replicate nearly any type of user traffic or protocol at line rate. And I have two examples over on the right-hand side. One is an enterprise class IXIA chassis. The other is kind of a small business class where it's got only 4 slots made for kind of a smaller line card. Whereas the enterprise class, and that's what we use within Kalo, within Cisco TAC, every single one of those slots has the ability to take a different line card. So some of them are going to have a mix of 1 and 10 gig ports or copper and fiber. We've got 40 gig IXIAs. We've even got, at the time of this recording, some 400 gig interfaces. And this IXIA chassis can, in theory, send 400 gigs of traffic nonstop in pretty much any flavor or protocol you can imagine. Now, when we have these larger enterprise chassis, TAC engineers will be able to control every single one of these ports individually. The result is that we might have dozens of engineers working on the same chassis simultaneously. Each group of people is going to be working on maybe only 1 or 2 ports at a time. And the way we're able to work with just those 1 or 2 ports is by using some special IXIA specific software. And as you may have already guessed, IX Explorer is one of those software applications. And we're going to be using virtual machines which have this software, and that's going to ensure that we can always maintain some level of control within the system. Now, when we look at some of our use cases, IX Explorer is one of the applications we'll be dealing with, and it's going to be the primary focus in this video, but other videos might dive into things like IX Network or IX Load. And as we can see here, every single one of these is going to have some very specific use cases. Each one kind of has its pros and cons in terms of what it could do best. But let's look at kind of why we would use each one of these. Within IX Explorer, and I would probably preface this by saying, in my experience, 80% of TAC SRs usually end up using IX Explorer when it comes to traffic generation. And part of the reason is because it's simple to set up and simple to navigate. And it's best for raw traffic generation where we need to introduce either static or varied L2, L3, and L4 protocol headers. Now, when it comes to stateful information, ARP is about as specific as it gets. When we're talking about that L2, 3, and 4 protocol headers, those are usually not stateful. What I mean by that is if I wanted to generate 400,000 unique TCP flows, IXIA is just going to send the exact same TCP packet, but with a different L4 port number, and potentially some different IP addresses as well to get that sort of number. But there's not going to be anything of value within the data itself. The packet payload will be gibberish, basically. And if it's TCP, we're not going to have a stateful creation of an L4 socket. So there's not going to be a three-way handshake. There's not going to be a three-way teardown. It's just sending raw TCP because the switch or router really can't tell the difference and doesn't care about any of the payload information. Now, IX Explorer also gives us the ability to control the volume in which this traffic is sent. If you just want to blindly send traffic at 100 megs per second, we could do it, and we will send traffic at 100 megs. But if you want to get more granular, maybe you want to introduce a certain size burst of packets. We want to see maybe how the switcher router handles a burst of 1,000, 1,500 byte packets. We could do that with IX Explorer. It also gives us the ability to act as a packet capture tool as well. And so if I wanted to capture a packet, including the .1q header or even with checksum or frame errors, we have that ability within IX Explorer. And we could also inject packets. Pretty much anything you can imagine. We can craft a packet from scratch. We can introduce errors. We can make it legitimate. We can even take a packet from a user's network. So maybe your customer says, hey, every time I send this packet into the network, it crashes the box. Well, we could load that exact same packet in our lab using IX Explorer, replay it back, and see what happens. So lots of very valuable information. But what if we need a bit more intelligence? We just don't want to blindly send traffic. Well, that's where something like IX Network comes in. Here, we can simulate L2 and L3 protocols, things like spanning tree, BGP, OSPF, and we can expand on those. Meaning I can create an OSPF neighbor, a virtual neighbor within IX Network, and I can create, say, 40,000 OSPF routes and have those routes advertised to my actual switch or router. And we could see how does it handle that sort of routing table. It could also do things like tracking detailed flow information. For instance, if one of our customers comes up to us and says, we need to test that this particular router can handle 1 million NAT translations without packet loss, well, we could very easily create 1 million unique flows, send them through our router, and IX Network has the ability to track every single packet in that 1 million flow test. And if a single packet comes up missing, out of order, sees too much latency, or whatever, it could be reported. So extremely complex flow statistics are one of the benefits of using something like IX Network, as well as our ability to simulate things at scale. If you need some sort of upper level of intelligence, right? I want to simulate a large number of routes or an actual neighbor or something that requires a back and forth, IX Network is where you go. If I want to simulate actual loads on something, then obviously that's where IX Load comes in. And this is not specific to network devices. For instance, if I wanted to create a web server and I wanted to test this web server against a certain number of users, IX Load gives you the ability to simulate actual users hitting your web page. And we can do things like have this user go to this web page, log in, navigate to this other page, download a file, upload a file, refresh the page, and then log out. And all that, including things like pauses and waits, so it seems more like an actual user, that can all be simulated at extremely high scale. Things like FTP. If I want to see how much FTP traffic a switcher router can actually handle, including the upper level of negotiation, that could be done. So this is also kind of very specific to some of the higher levels of intelligence where our protocols can be bidirectional. They're stateful, they know what's going on, but we could also test some of our protocols like HTTP, FTP, DNS, etc. So very powerful when it comes to simulating users, whereas IX Network is maybe powerful for simulating other network devices. But overall, each one of these applications, as you could tell, has some very specific use cases, and the videos that follow will look at some of the use cases for every single one of them. All right, so enough about figuring out what IXIA looks like. Let's start getting into some of the meat and potatoes of this presentation. How do we use it? And for that, we need to start off with a Kalo case. And what I've done here in my main info, this case, I've simply asked for a single 9300 switch with two IXIA ports, one connected off port 1, the other connected off port 48. And when I go over to my booked devices, we're going to have at least 4 items checked out. First off is our IXIA client. This is the virtual machine that we are going to use to connect to my ports. And each one of the ports are listed down below. So this is TS IXIA XG12-1 port 11/1, and I have port 9/16. So these are the 2 ports I will be able to use to simulate my user traffic. And then down below, I have the actual switch itself. Now going to our RDP client here, there's 2 ways to get connected. One is simply remote desktop protocol to this IP, or you could use the VMRC application within Kalo in order to get connected. But for me, I'm just going to do RDP, and I've got it right here. Now, once we load onto the web application, and again, if the lettering here is a little too small, a little too hard to read, you may need to adjust the video quality, so just FYI there. I'm going to double-click the IXIA IX Explorer, hit yes for the security, and now it's going to prompt me for the chassis IP of the ports that I want to connect to. I'm going to navigate back to my Kalo case here, and with each one of these ports, hopefully both ports are on the exact same chassis, and I could tell that because within the group, it gives me the chassis IP. So my chassis is 172.18.120.46. So I'm going to copy that, and I am going to paste it right there. And when I hit OK, I'm not going to save this config, because this is just a video demo. My chassis starts off as red, and it should turn to green once it's connected. There we go. So now my chassis is connected, and that means I can open it up and see all of the different line cards which I have the ability to use. But realistically, only 2 of them are the ones I care about. I care about ports 11.1 and ports 9/16. So I'm going to open up card 9, and here's port 16. But before I can take control and start doing something with this, I need to create a login identification. The way I do that is I go up to the very top here where it says multi-user, and then log in. Now, this can be anything you want. You can make up a name. There's no password. It's just a username only. So typically, I like to use my CEC credentials just so that if someone else has a problem, they know who owns that port. So KRGABRIE, that is my user ID. And once I'm logged in, we can see in the bottom right-hand corner here, it says KRGABRIE is now logged in. Once logged in, I can now right-click this port, and in the menu that appears, I can take ownership. And we'll see that my name now appears next to the port number. And I could do that if I hop over to 11 and then 1, I could do the same thing. I can take ownership. Now, if for some reason I need to release my ownership, I just need to right-click again, and you have the option of clear my ownership. And if I do this option, it'll now remove my name from that port, but it'll do it just for this one port. So we can see here port 16 still has my name associated. What you do not want to do is the clear all ownership option. This will kick everybody off. So if we look here, we can see that there's a user here using port 4, another user on 6 and 7, someone else down below. So it won't necessarily stop their traffic, but it is kind of annoying if you get kicked off your own ports. So just be aware the two options you really clear about are either clear my ownership or take ownership. Now, once I have ownership of the two ports I care about, there's a lot of kind of extra fluff here. So if I open this up, we can see I have all these extra ports that I don't care about, not to mention all the other line cards. So the next thing I want to do is I want to hop up to View, and then in the menu that appears, I want to click the Owned Ports Only. Now that I've logged in and taken ownership of my two ports, it should give me only the ports that I care about. And obviously, if we need to go back, we can kind of unselect this option and it'll bring me back to the page I had before. But again, right, so I'm just going to go here, owned ports only. So now I should have just these two interfaces. I'm going to minimize these last two values. And now let's talk about what exactly it is that we are seeing here. First off, port 16, we'll see that this little icon is green. And this is now referring to kind of the L1 aspect of this. We want to make sure there's some basic IP connectivity. And one of the best ways that I could check to make sure I have the right interfaces connected is to pull up my switch. And I'm going to pull this off to the side. So my switch should be connected to ports 1 and 48. So if I look at show int gig 101, I could see the protocol is up, line protocol is up, and if I were to int gig 101, if I were to shut it down, then this icon should change from green to red. So let's do a shut, and there we go. So port 101 is connected to card 11 port 1. And if I no shut my port on the switch, this should go green. There we go. Back to green. So now let's check the other side. If I go int gig 1048 shut, now 916 goes down. And if I do a no shut, it should bring it back up. And it does. Perfect. Well, what happens if your ports do not go up? Or you're having some issues, or maybe you need to try to force a different speed. Well, that's where we now have the option of port properties. And we can get there either by right-clicking the port and going to properties down at the bottom, or just double-clicking the port properties here. And this is, you'll notice I have the port selected. So if I click something like packet streams, I get a different view. If I go statistics, I get a different view. So I'm clicking the port and then going to port properties. Pull this back into the screen here. We could see now I have the ability to change some of the L1 features. Here, auto negotiation is enabled, but if I wanted to hard code speed and duplex, I simply deselect this and pick whatever speed or state I want. If you're familiar with some of the more default or some of the more advanced PHY registers, we have the ability to modify those as well. So I can click the registers, and if you know your individual register data, you can create a very specific profile. But as you can tell, this is a little complex and not necessarily the easiest to follow. But things like the control register is here, the status register, the PHY IDs, the auto negotiation advertisement. So if you're ever trying to simulate an issue with a user and their device does not want to link up, if you know their PHY settings or what the PHY registers are, you can potentially change what is advertised here and see if the switch also fails to bring that interface up, or if you need to modify one of these registers in order to make it work. In addition to the registers, we also have things like simulating a cable disconnect. So if I were to select this and hit apply, it'll bring the port down as if someone physically pulled the cable. And so if you need to simulate maybe a cable disconnect on your switch or router without doing a shut no shut, this is how you can accomplish that. So I'm going to unsimulate that, reapply, and my interface should come back up. There we go. And I'm going to go ahead and select gig full duplex and select all the different options here and reapply this as well. We might need to resimulate this just so it goes back up to a gig. So let's see. So right now I'm disconnected. Now I'm connected, and that should allow me to negotiate to a gig a second. Some of the other things that we might be talking about, and this is usually going to come up a little bit later on, is the transmit modes. We're going to start off by doing just basic packet streams, but some of our other options will go into the advanced stream scheduler. The one thing I want to point out is that sometimes some of the line cards within Kalo have the ability to use either copper or fiber. And so if you run a copper cable to your switch, but the IXIA is configured to look for a fiber transceiver, the link will not come up. So if you need to toggle between one or the other, this is the page you would do it on. Now, some of the other things we can also talk about, I'm not going to go into detail, but again, PHY registers here. If we want some sort of layer 1 flow control, or we want to simulate layer 1 flow control, we can accomplish that here, and we can either send only, receive only, or send and receive flow control. There is status information to let you know the link is up, general information, which we really don't use too much, and we also have OAM, which is operation and management. So typically this will also be bundled with CFM, connectivity fault management, but for the most part, as a general user, you're going to be focused on auto negotiation and your transmit modes. So just be aware if your link's not up, check these and check your switch or router as well. And if the link still isn't up and all this matches, then you could just have a genuine cabling problem. All right, so moving out of the port properties, let's talk about what else we see. When you click packet streams, this is the stream window. And so one of the things that we're going to cover in the later parts of the videos or the next videos to come is how to generate streams. And this is going to be our starting point for subsequent videos as well. Whenever you want to create a flow, you simply need to right click, go to new stream, and a stream has been created. It's now up to you to double click this and start navigating through all these options in order to build a packet from layer 2 and up. So we could see we have lots of options, which I'm not going to go into all of them in detail, but we could see we have the ability to adjust things like size. We can introduce CRCs if we wanted. We could simulate IPv4, V6, FCOE, V4 on V6, V6 on V4, ARP, IPX, TCP, UDP, lots of different options. In addition to this, we could also do things like MPLS, add .1Q tags, ISL tags, etc. And I can modify things including my source and destination MAC address. So extremely powerful set of controls where we could build pretty much any packet we can imagine. In addition to this, we also have the ability to control the stream. So I can give it a name here. I can call it my name, whatever I want, or my name 1. And I mentioned earlier we could do things like send continuous streams or send burst. Those options are here where I can send continuous bursts, continuous packets. I can advance to different types of flows. And here the default setting is to send at 100% of this link's capacity. So that can obviously be adjusted as well. And then finally, we can look at the packet which we are sending, which right now with nothing configured, it is a generic packet with this source and dest MAC and this ether type. It's essentially saying I've got a length of 1, and then there's some padding or gibberish down below. So again, we'll talk later on in the other videos about how we could build up some real world packets. But for now, just know that when you get to the creation, this is how you do it. One of the other tools that we have within this is our packet statistics. And here I could see there are 2 columns. One is a cumulative counter. This is how many packets total since these counters were cleared. And so the valid frames received right now, we have received a total of 6,712. And we see that this is slowly going up. It's 13, 14, 15. This is likely a result of the BPDUs being sent by the switch right now. Every 2 seconds, a BPDU goes out. Plus, occasionally we send things like VTP, CDP, DTP, all those layer 2 protocols. The column to the right represents our current rate, and this changes. We could see that the bytes received fluctuates between 0 and a non-zero value. Every second this is refreshed. So if you are constantly sending a flow of traffic, then this second column will be non-zero. But if the traffic is simply a burst that appears in 1 second and disappears the next, you will see something like what we have highlighted here, where we're mostly 0, we get a packet, so we register the bits in that packet, and then we go back to our 0 rate. Within this, we also have the ability to define individual user statistics, and this is configurable. So if I were to right click this, or I think, let's see, is it double click? Yeah, there we go. So if I double click this, I also have the ability to adjust some of what I'm seeing here, and I can control some of the alarms where if I'm looking for maybe one particular source test IP or some type of traffic to appear, know that we have the ability to set some of those fields, but we're limited to, I think, a maximum of 5 user-defined captures. But some of this is going to be configurable, and then the rest, if I just want to clear it out, you simply right-click and clear all statistics, and that will reset it for you and start it back from 0. Now, when we are ready to start sending traffic, one of the things that we could do is simply go to our packet streams, right-click this, and say Start Transmit. We also have up at the top a button which will do the exact same thing. So depending on what port we have selected, I can start transmit simply by clicking that. If I want to stagger it across maybe multiple ports, I have that option, or I could stop my transmission. What you'll notice here, might be a little hard to see, there's a small black arrow to the right of this green icon. So if I stop it, note right where my mouse is, we're going to see that black arrow disappear. Stop. See, now it's gone. This is how you could tell whether or not your interface is sending traffic. So if I start this, we'll see I now have that little green arrow. This one is not receiving anything. And if I go to my statistics view, I now see the rightmost column is populated. So this tells me the way I'm going to read this is I'm currently sending traffic at a rate of 1,480 some odd thousand packets per second. So about 1.4 million packets per second. And every second this is refreshing, meaning I'm sending at full line rate every single second. It is just one big burst that never stops right now. My cumulative counter tells me that the total frames sent is now well over 100 million packets. And I have something similar for bytes, both current bytes received and or total bytes sent and the active number we have here. So total and current. There are other settings we can look at here. I'm not going to get into them in too much detail, but what I do want to highlight is if I hop over to the other side, let's see. All right, I may not have my switch configured yet. Either that or this is just a garbage packet. I think that's also part of it. So let's just do this real quick. I'm going to do a destination address of all 2s so that it's unicast flooded out. Great. All right, and apply. So now once you make a change in IXIA and you hit apply, that should automatically apply your changes. So any change you make is done on the fly. It'll automatically just take effect the moment you make the change. So just be aware that all this should be pretty quick. Now, if I hop over to my statistics, I'm still not getting it. So let's see. Show MAC address table. 10. I think I know what the problem is. I am sending on port 111, showing gig 1048. Yeah, so If I look at my interface now, I can see I'm getting quite a bit of traffic, and I know what the issue is. It's part of one of my other videos in gig 1048. Switchboard mode access, switchboard access, VLAN 10. So I'm going to watch and make this go to the forwarding state. But one of the things that we should see now is as soon as this transitions to a forwarding state, this traffic will now enter the switch and be forwarded, and it should flood to this other interface. So right now we're learning, and once it goes forwarding, you're going to see this column here will now start going nuts because it's now going to be receiving all the traffic that the other port is sending. There we go. So we just went forwarding, and now we can see my rate in terms of valid frames received is an extremely high value. So packet or stats view, frames sent is 1.4 million. I've received 1.4 million, and this is an active counter going on right now. If I were to stop this traffic, then that should immediately drop, which it does, but it still gives me the total received counter. So this is a very high level overview in terms of just how do we get connected? What are some of the fields that we're going to be looking at? How can we check some basic L1 negotiation? We checked port ownership and controls, and I showed you a little bit about how to set up a basic flow, but we're going to get into that in more detail in the coming videos. So I hope you found this particular video helpful, and stay tuned for some of the others where we're going to dive into how to make some more complex flows, how to do things like access or .1 queue tagging, changing MAC addresses, multi-host, all that stuff and more will be covered later on. Thank you and have a great day.